Hey everyone, I'm Ashley, a developer advocate at Writer, and today I'm going to be walking through a text-to-SQL agent powered by Writer's Palmyra X5 model on Amazon Bedrock. A brief overview of this text-to-SQL agent. So it'll take natural language questions or queries about an enterprise financial data set. It'll then translate it into SQL, execute it on the data set, and return the results. But why exactly is this so powerful? Even though we are going over a fairly common use case of querying enterprise financial data, it brings up the fact that developers still today are encountering limitations when working with LLMs. Think of complexities when handling complex enterprise schemas, context limitations, and scalability. But that's what Writer's Palmyra X5 was built to address by offering deep thinking and tool calling, large context windows, and low cost. But let's actually see this in action. So let's start with a quick demo before we get into how exactly it's built. So I have my program running, and I'm going to query my text-to-SQL agent with find the top 5 employees by total sales value. If we were to run this, we can see that a few things start to happen. But while we let this run, it's good to kind of zoom out and show that while this demo focuses on one subset of enterprise examples, it's really meant to act as a blueprint for more enterprise use cases, which Writer specifically caters to. But now that this query is run, we can see a few things happen. We can see that there are a few tools that are being called, specifically getSchema and query database. We can see the SQL query that is returned to us as well as the results. So we can see that Joseph, Kelly, Anthony, Jessica, and Nicholas are the top 5 employees by total sales value. So this diagram does a good job of showing how this text-to-SQL agent was actually built. So it starts with a user interaction with the model. Then the Amazon Bedrock agent, or in this case, Writer's Palmyra X5, will process the request and look at the tools it has available to it, and then follow the workflow defined in the agent prompt to actually call these tools. These tools sit in a Lambda function, where we'll first call getSchema to understand the database structure, and then we'll call query database to actually generate the SQL query and execute it on the dataset. Each one of these tools use their own AWS services, but this Lambda function is really meant to act as the glue that kind of connects it all together. But now that we've seen how it's built, how do we actually set this up? So the whole infrastructure, all of the AWS services and configurations, is provisioned by a single setup script called initialize environment, which is what we're looking at. And it automates everything the agent might need to set up the workflow I just showed. And this would take a few minutes to run, so instead I can show the finished results in my AWS account. So starting off first with our Lambda function that again acts as the glue that kind of connects all of these AWS services together, we first have our getSchema tool, which uses a glue data catalog to understand the schema of our enterprise financial data set. We can also go over to our AWS Glue catalog, and you can see that our initialize environment script safely got all of our tables into our catalog so that our tools can now understand the schema. Our second tool is the query database tool. And again, this uses Athena as well as an S3 bucket to take the generated SQL and actually execute it on our enterprise financial data set. Again, if we were to go over into our S3 bucket, we can see all of that enterprise financial data is safely resided within my AWS account. Again, all of this was possible because of our initialize environment script that, again, automates everything the agent might need to set up the workflow I showed. But now that we've understood kind of the infrastructure that powers this text-to-SQL agent example, we can now walk through a more complex prompt and see how our Writer Palmyra X5 on Amazon Bedrock agent actually performs. So let's now ask a more complex question, more specifically, for each product category, who are the top 3 sales employees based on the total revenue they generated within that category? So this is more complex because we should expect to see in our SQL query things like ranking and aggregation, for instance. But if you were going to send this off, we can start to see the tools being called. So first we're calling getSchema to understand the schema of our enterprise financial data set, and then we are taking that, generating a SQL query, and then actually executing it on our data set via the query database tool. Now that we've gotten the result back, we can see that the SQL query is fairly complex. We're seeing things like rankings, aggregations, as well as joins. So again, this was fairly complex, and Writer's Palmyra X5 model was able to seamlessly understand the schema of the enterprise financial data set, generate a SQL query, and then execute it on our enterprise financial data set, all possible through Amazon Bedrock and their associated AWS services. We can also see the results, which are formatted nicely to include different categories as well as the employees, the top 3 employees, and their associated sales values. Great, now that you've seen one powerful example of how to use Writer's Foundation Palmyra X5 models on Amazon Bedrock in a text-to-SQL agent example, you can get started by heading over to our developer docs to learn how to invoke Palmyra models on Amazon Bedrock in a variety of different examples. Or you can test this text-to-SQL agent example out yourself in our public AWS examples GitHub repository.